What's up everyone, and my name is Saurabh Kumar, and today we will be discussing about the preliminary investigation report on the Pakistan International Airlines A320 registration Alpha Papa Bravo Lima Delta air crash. This was a scheduled flight from Lahore International Airport to Karachi on the 22nd of May 2020. So this report has been issued by the Pakistan Civil Aviation Authority, and we will be decoding it. I will not be going over the entire report, but the large key sections, the preliminary findings, is what we will be discussing. So moving on. Alright, so let's go to the brief description first. The accident occurred on the 22nd of May at 13:05 hours Pakistan Standard Time. You're supposed to have, the investigators from the manufacturer of the aircraft. Then you need to have the investigators from the engine manufacturers, because the engines are not necessarily, or actually they're never produced by the manufacturer of the aircraft. For example, in Airbus we can have engines developed from Rolls-Royce, we can have it from Safran or IAE. So it is important to understand perspective from all the professionals who come from different walks of life. So to begin with, a brief description de dete hain pehle. So this was on 22nd of May 2020, as it is highlighted over here. Right. And the flight took off at 13:05 Pakistan Standard Time from Lahore Allama Iqbal International Airport. The registration was Alpha Papa Bravo Lima Delta. This was a regular flight with 8 crew members on board, 1 captain and 1 first officer. So Airbus A320 is a 2 crew cockpit. You need to have minimum of 2 pilots, that is the captain and the first officer. And along with that, it has 6 flight attendants with 91 passengers on board. At 14:35 local time, which was roughly about 1.5 hours later after the takeoff time, the aircraft performed an ILS approach. Now, what is an ILS approach? We will talk about it later. The runway to land on was runway 25 left. So every runway is given a designator according to the magnetic orientation of the runway. So 25 basically defines 250 degrees from the magnetic north, and it touched down without the landing gears. Now this is a very interesting part, that why did this happen? So far no one has been able to ascertain this, but let's see. Was it because of a system design principle? Was it because of a malfunction? Was it completely because the pilots were disoriented? We will find this out as we learn and dig deeper into the report. And the plane rested on both the engines, which is evident from the pictures which we have seen from the CCTV footage located at the Karachi airport. Both the engines actually, they scrubbed the runway, and there is evidence of that. Flight crew initiated a go around and informed Karachi approach that they intend to make a second approach. So they wanted to come back for a second landing. They declared an emergency and stated that both the engines had failed, obviously because the engines had been so badly damaged upon being scraped on the runway ki uske baad there was no chance. There might have been fuel leakage, hydraulic supply failure, electrical component failure, that it was too difficult for the engines to perform at their normal operation. Then the aircraft started losing altitude, of course, because it could not sustain its lift. There was no thrust, so it started gliding. It crashed in a populated area, I think it is called Model Colony, short of runway 25 left by just about 1.3 kilometers. An immediate subsequent post-impact fire initiated, obviously because the aircraft had lots of fuel left. Out of 99 souls on board, 97 were fatally injured and only 2 passengers survived. And I believe one of the passengers was the chairperson of one of the leading banks in Pakistan. On ground, 4 persons were injured. However, 1 out of these reportedly expired later at a hospital. Alright, so unfortunate that this accident occurred. This was a completely avoidable accident. Every accident is avoidable, but accidents are inevitable. I think they will continue to happen, but we have to continue to learn from our mistakes. So this basically shows all the officers and the leading investigators involved. I'm not going to delve deep into this and the scope and the purpose of the investigation. So largely it summarizes that the purpose of any investigation is basically to improve the safety of aviation rather than blaming or assigning blame to any particular individual or a company. But होता क्या है कि हमेशा आपने देखा होगा सबसे पहले blame pilots को दिया जाता है कि pilot error था. Now it has been proven and the officials have come out that pilot error was one of the major causes which resulted in this accident. But you cannot assign the blame just on pilots. इसमें ATC की गलती भी मानी गई है. They were not directly involved, but they could have taken a few measures probably which could have avoided this accident. So initially it would have been wrong to blame the pilots, but at the end of the day you have to come out with the cause of the accident, and human error is being largely attributed as the cause. The authorities have said that the aircraft was in airworthy condition, which means that it was technically a safe and sound aircraft. Aircraft में कोई problem नहीं थी. But again, the purpose is not just to blame the pilots and move on. The idea is to now what changes can we bring in terms of training, in terms of our standard operating procedures, in terms of implementing of new policies. What changes can we bring in the aircraft insurance so that this accident does not occur? So can we redesign the principles of the systems? Can we redefine the logic? So all this will take some time, but in due course of time, we will see some recommendations which will come out of this report as well. Okay, so now आगे बढ़ते हैं. Custody of records of aircrew, ATCOs and aircraft. So immediately after the accident, the investigative authorities will take hold of all the documents of the pilots, their schedule, in the past few hours before the flight or days. Were they fatigued? Did they sleep well? What was their rota like? How often they had been flying? They will check the maintenance records. When was the last maintenance done? When were the checks carried out? And interestingly, in this particular case, because the aircraft was grounded for a very long period of time because of the COVID, since the Pakistani airspace was closed, even that aspect would be looked into, whether there was a degradation or were the pilots proficient enough to carry out their duties. We call them were they current? Like pilots have to do 3 takeoffs and 3 landings in every 90 days. They have to do various simulator checks on an yearly or half-yearly basis. So even that aspect would be looked into it. This basically summarizes, this table summarizes the entire description of the airplane. The manufacturer was Airbus Aircraft, a European-based firm. The type of the aircraft. So you can see registration entry into service 2004. So not a very old aircraft, so been in service for about 16 years or so. Engine serial numbers and total flight hours and total flight cycles. So your flight cycles are your takeoffs and landings, and your flight hours are basically total number of hours within which the aircraft was actually in operation. Okay, now this is very interesting. This image has been captured from the Google Maps, and the crash site. Let me pull out a highlighter. I think I can do that by taking this pointer. Right, okay. So this is the threshold of the runway 25 left. This one here is your runway 25 left. The aircraft was coming from this direction. And this one is your runway 25 right. So these are 2 parallel runways. It was expected to land over here and vacate via this taxiway or probably this one and backtrack and come to the international terminal, which is located over here. And this is where it crashed after making one unsuccessful landing, going around, and this is the model colony town where the aircraft actually crashed. Okay, if you can come further down, this is the aerial shot. So the aircraft came straight down here and it crashed in this particular alley over here. Straight, as you can see, there is no damage over here, no damage over here. However, it seems like the aircraft just came in and crashed over here. I'm actually pretty surprised because the damage is very concentrated in just one alley over here. The destruction has largely been caused to the rooftop of the houses. No building has been completely demolished, and I think one reason for this is largely because the aircraft was coming at such a slow speed because it had stalled. It was just coming down. The speed was, I think, roughly close to about 140 knots or something, which is very close to your landing speed. And so fortunately, at least the damage on the ground was kept to a very minimum. And here in the investigation, they have mapped all the components of the airplane. So I think the green ones are the parts which have been found over the rooftops, and the orange ones are the ones which have been found on the ground. This is very important for the investigation, especially if the cause of the accident is due to a technical component failure. Then what the investigators do, they basically mark every component. For example, over here, I think this is the part of the wing or the stabilizer. This looks like the elevator, and you can see here all the damaged parts have been laid out on the ground. बहुत मुश्किल काम है ये to identify basically कौन सा part कहाँ पे जाता है, because उसका पूरा analysis करना पड़ेगा. And these are the specialists who basically are are knowledgeable in this field of study. Here you can see the engine component has been kept on the ground as well. Right, so I think this whole structure over here is the fuselage component. So I would like to assume that this is the engine, could be the right or the left. And over here you have the gear assembly, which is located just behind the engines. And this seems to be like the fuselage structure, the main body of the aircraft. And again, we can see how the entire structure fell in a single straight line linearly within this alley over here. And over here as well, we can see looks like one of the motors, probably from the engine, or it could be a part of the tail cone. It's very hard to say. It could be any one of the pumps for hydraulic lines or for the pneumatic air pressure. So the manufacturer's responsibility is largely to identify these components, because they are the makers of these components, and bring all these components to another remote facility where they can be assembled and a skeleton structure can be prepared. We will see that now in the below pictures. So here you can see as well the scavenging effort. So this is the wing. I think this is the left hand side of the wing. Yes, this is the right hand side of the wing. Here we have the right engine, and this one is the left engine, which is more destroyed than the right one. So probably the left engine had the first impact upon the ground. This over here, I think this is the fully authority digital engine control, also called the FADEC. It's mounted on the side of the engine. This basically manages the entire operations of the engine. It's called full authority digital engine control. Again, we have the bogie of the landing gear, the right as well as the left. Again, you can see the left is completely destroyed. The right is still intact with the tires, but the left one, the wheels, I think the rubber has completely melted or it has come off, but the right is still intact over here. Some interesting components again we can see over here. This looks like the cowling of the engine. Again, by the curvature, seems like parts of the engine. Some extra, they look like components from the avionics, I believe, since I can see a lot of wires over here. This panel seems to be from the cockpit. Yes, it is from the cockpit. Actually, this is the top-down view in this way. These seem to be the limitations, the cell call, this is the standby instrument, and this one is the, I think, CPDLC, cockpit voice digital communications. Yes, so this should be actually upright in this way. This seems to be the panel from the EGPWS, which is Enhanced Ground Proximity Warning System. This basically would have played a very important role because one of the modes or the warnings that it does provide is about the landing gear. So if your landing gear is not down by 750 feet above the ground level and you're coming in for a landing, the warnings would chime. It would state to the pilot, hey, buddy, listen, your landing gears are not down. Do something about it. You're getting close to the ground. So there are a lot of oral warnings, visual warnings, which would have come, and we will hear this in the cockpit voice recording as well. Why they ignored it, why the landing gears did not deploy, why they did not come out. We'll have to find out exactly what speed the aircraft was coming at. Were they disoriented? Had they forgotten? Did the aircraft not permit the landing gears to be extended because it was higher than a certain threshold of airspeed? So in Airbus A320, if you're above 250 knots, if the landing gears are retracted, they will remain locked. You cannot extend them out. This is as a safety measure because that is a structural limitation, that the landing gear should not be extended out, because the limitation is the doors. The doors will not be able to take that kind of air resistance. Once they open up, if your aircraft is higher than 250 knots, then there's a risk of structural limitation, and hence you have to be at 250 knots or below in order to extend your landing gear. Once the landing gear is extended, then you can push your speed to 280 knots. But now if you want to retract it inwards, then the limitation is 220 knots. So these are various limitations that pilots are supposed to know by memory, and this is again as part of the FCOM as well. So earlier, as I was talking about, that all the parts are scavenged from the crash site and they are laid out in this remote facility, which could be in a hangar or open air facility, and they are laid out on the ground just to understand what components have been scavenged, what can be recoverable, how we can retrieve information from various components. So if you will see over here, this is the left wing. The right wing has not been recovered completely. These are your engine number 2, engine number 1. This is the cockpit area, and that's the rear of the aircraft. So this is how the aircraft is actually laid out on the ground, and you can see these markings here, white markings on the ground, which basically shows the dimensions of the Airbus A320, so to speak. Sorry for that Mickey Mouse drawing. These are the most important components from the crash site. So this one is your flight data recorder, and this one is your cockpit voice recorder. This would have recorded the data for the last 20 hours of the flight, or 25 hours, depending upon the model. This would have recorded the last 2 hours of the cockpit voice recording. These two components essentially will determine what were the chain of events which finally resulted in the crash. Now, we all have heard about the ATC pilot communication, which is all over the YouTube. However, we don't know what were the internal communications which were taking place between the pilots or between them and the cabin crew and the PIA announcements. So this would have recorded every voice, from their breathing to their communication with each other. So that is essential basically, and that is what we have learned, that the pilots were actually talking about the coronavirus impact upon their lives and their financial situation, and they were completely distracted. They had not followed any of the standard operating procedures, which is a way of communication. In fact, if you will hear the cockpit voice communication, the controller tells them to turn left heading, confirm left heading, and they say G sir. So there was a use of non-standard language. They did not use English language. They did not follow the protocol of communication. Certain checks are to be done. Certain way of communication is done in a non-ambiguous manner. Apparently that was not done. And flight data recorder, which is here on your left hand side, would have recorded every single parameter of the flight, and this is what we will see in the next coming slide as well. So why the landing gear was not down, or when it was up, what was the flap position, what was the slat position, every parameter would have been recorded by flight data recorder. And this basically helps the investigators to simulate the environment in which the aircraft was flying at the time of the crash and moments before it. So here we can see how they were basically retrieving the data from the flight data recorder and the CVR, and this is very sensitive information. And you can see that no major damage was done. So this is so robust and structurally integrated that it can basically take a large amount of forces, fire, water pressure upon it before being completely destroyed. Hardly there has been a case where the flight data recorder gets completely destroyed uh, you know, beyond which the information can be retrievable. It's called a black box, but however, you can see it's orange in color so that it is easily distinguishable at the time of retrieving the the destroyed components. So this is what essentially I want to talk about the most, the preliminary findings, and we are going to go over each point, and I'm going to help you explain the various terminologies used over here along with the actual approach chart for Karachi airport using the Lido charts, which is what pilots essentially use when they have to prepare for the approach briefing. So let's go over it word by word. The investigation so far into the available evidences, that is the FDR and CVR readouts, which is what we saw above, the preliminary assessment. Footages from the CCTV, security cameras at the airport and Karachi approach, radar data, etc. Following has been revealed and validated as the primary findings. So these accounts are based on the recordings from the data, the CCTV footages, maybe eyewitnesses' accounts, and from the controller reports. The weather at the origin, en route, and at the destination airfields was fit to undertake the flight. So we did not have any serious weather, so to speak. On the set date, the PIA flight took off from Lahore at 13:05, and the departure from Lahore and cruising flight was uneventful. However, there were no standard operating procedures followed, which is what we are aware of now as the aviation minister announced at the parliament. The crew also did not follow the standard call outs. So what are these standard call outs? I will take you through. So we use particular phrases. We just don't speak in English like the way we speak colloquially or जैसे हम informally बात करते हैं हमारे friends या हमारी family के साथ. There is a certain way of speaking. There are certain terms which you are supposed to use. So for example, if you have to say no to someone, you use the word negative. आप नहीं बोलेंगे, आप no नहीं बोलेंगे, आप ना नहीं बोलेंगे, आप अपनी गर्दन नहीं हिलाएंगे. You have to say negative. It is absolutely clear in the minds of all the individuals that this means no. This is because we all are from different nationalities, we all have different upbringings, we come from different cultures, and even if we are speaking English, we all don't speak the same kind of English with the same dialect. Hence, it is very important to use the phonetic alphabets. आपने सुना होगा Alpha, Bravo, Charlie, Delta बहुत लोग use करते हैं, especially people from the aviation field and from the marine or the navy. So moving on, it also says that they did not observe the CRM aspects during most parts of the flight. This is very critical to understanding why the crash took place. Any crash is not the result of just one error. It is a chain of events. उसकी जो preparation होती है accident की वो पहले से ही start हो जाती है. Now we are basically working our way backwards in trying to understand how they became so callous or basically oblivious कि उनको पता नहीं चला और वो इतने disorient हो गए थे कि अगर आप भी हम जब देखेंगे जो अप्रोच के लिए प्रिपेयर कर रहे थे अपने एयरक्राफ्ट को, they just did left, right and center whatever they wanted to do. कहीं भी SOP नहीं फॉलो किया. And it really surprises me कि someone so experienced at that caliber with that many hours of flight hours behind their back, under their belt, can do such grievous errors. So this is actually a human factors issue, looks like that. Point number C, area control Karachi East. So basically ये एक radar controller है. So when you're entering the Karachi airspace, you first speak to the area controller. They cleared the flight PK A303 for Nawab Shah 2 Alpha arrival procedure. अब ये नवाब शाह 2 Alpha arrival क्या होता है और ये स्टार क्या होता है, standard terminal arrival route. To keep it simple, think of it as a road in the air. It's called an airway. Okay? When you're coming into an airport, आप अलग अलग direction से आ रहे होते हैं. Actually, let's take, I think it's better to take a new note so that it will be easier for me to explain. All right, so let's say this is your airport over here. Okay, this is your runway. Sorry, ये हमारा हो गया एक runway और ये हमारी airport है मान लो. Now the aircraft could be coming from here, it could be coming from here, it could be coming from here, it could be coming from here. They are coming from all different directions. But there is a standard pattern जिसे हम बोलते हैं STAR, Standard Terminal Arrival Routes. So let us pull another chart from Lido application and STAR. So if you see here, okay, this is Nawab Shah to Alpha. It's right over here, this one. So the airplane was actually coming in this direction. Okay, and you see this black solid line. This is the arrival route, which is taking the aircraft here at the airport, at Karachi airport. So let's say if someone is coming from the western side, he will be coming from LOTAT 2 Alpha or 2 Bravo. This is his routing. Someone is coming from here, this is his routing. Someone who's coming from here, it's Minar 2. You follow this. Someone is coming from the eastern side, you're following this route. Okay, so all these are basically routes that you're supposed to follow, and imagine these are your roads, systematic roads, and so that the traffic comes in a very organized manner when it comes into the airport. Okay, so I will come back to this chart later because this is a very important chart. This basically helps us to understand what exactly was happening, where were pilots, at which altitude were they, and where were they actually supposed to be at. So we will just come back to this particular chart in a bit. Okay, so continuing with paragraph number C. तो एयरक्राफ्ट को क्लियरेंस मिल गई थी फ्रॉम द एरिया कंट्रोलर of Karachi East because the aircraft was coming from the eastern side. It was coming from Lahore and it was to expect ILS. Now what is ILS? Instrument Landing System. I will explain to you with the help of a drawing for runway 25 left. The flight was later cleared at pilot's discretion. Again, he अपने मुताबिक at his own terms he had to report at a point called Makli. This is like if you're driving a car and hey, you know what, you have to report at this particular T junction or at this particular roundabout. So think of it in that way. And this point is located 15 nautical miles from radial, at radial 075 from Karachi VOR. Okay, so a few technical terms over here. I will have to explain all these. And descend to flight level 100 and later re-cleared for flight level 50. The aircraft was handed over to Karachi approach. So from Karachi Control East, it went to Karachi approach and was cleared descent to further 3000 feet by the time it reaches Makli. Okay, so the workload was increasing continuously. First 10,000, then 5,000, then 3,000, and at their own discretion, which means that pilots had to reach 3000 by the point they were at Makli, and they had to do whatever they could do. And this is where things happened incorrectly. Everything went haywire in this particular scenario because they came in too high. So let us go back to our drawing board and let's try to understand. But before that, let us open the Karachi chart again. So as I mentioned previously as well, कि basically this is Nawab Shah to arrival, okay, and they are essentially flying on this route. They're coming like this, okay. Here is the point Makli, and this is the routing that they were supposed to follow. Make a right turn over here. There's another point called Poonam where they were not supposed to report. They were supposed to report at a point called Makli, which is this triangle over here. And if you see on the chart here, you can see R075, which is essentially radial from a VOR from Karachi VOR. Okay, so Karachi has a VOR. If we can open a VOR chart here for 25 left, So we will see that the VOR is 112.1 Kilo Charlie. So there's a station located at Karachi International Airport, a VOR station. So let's get back to our star chart. Alright, so this is where your VOR is located at, this one. This is the frequency for the station. What exactly it does is it basically sends signals 360 degrees on this particular frequency 112.1, and it is located here at the airport itself. So all across, let's pull out another drawing to make it simpler to understand. Okay, so imagine that this is your station. Okay, this is located on the ground, and this is your north. So this is your 360 degrees or 0 degrees. This is your 90 degrees. This is your 180 degree radial, and this is your 270. So they were told to report on point called Makli, which is located on a radial 04. Let's say this is Makli. Okay, so this is exactly the radial. It is basically let's say a strand which is coming out from the station, okay, 360 degrees, and the aircraft would be on this particular radial 075, and the aircraft could be on any point. So it could be wherever it is coming from, but it has to be on a certain radial. Given the aircraft's position and where it was coming from, this was on radial 075, just to keep it simple to understand. So imagine this is like a clock, and we go 360 degrees from 0 to 360. Alright, now since we are over here, I also want to take the time to explain you what is an ILS. Okay, so imagine that this is the runway. Okay, they said the runway is 25 left. What exactly is 25 left? L basically stands for left or right runway. So there were two runways at Karachi. So that is simple to understand, right? The aircraft is coming from here. This is 25 right and 25 left. So this was using 25 left. All right. Now what is an ILS? Again, I'm not going to go very technical with the knowledge, but basically what an ILS is, it's an instrument landing system, and it centers the aircraft to the runway center line. You want the aircraft to land here, right, on the center line of the runway. So there are two beams. One is for lateral guidance, which is your side to side guidance, and one is your vertical guidance. So you want to keep your aircraft exactly on the center. There are two beams. So imagine this is your lateral beam, okay, center beam. So if the aircraft is coming from here, it will track this particular path, which will be exactly on the center line of the runway. That's one signal. Now let's look at it from the side point. Okay, so let's say this is the surface. Okay, this is where the aircraft will land. Now this is your vertical profile. Okay, and let's say if I'm trying to make it a bit 3D, this will be your lateral profile, the center line of the runway. But here I'm concerned about the vertical profile. Sorry, that drawing is very confusing. Let's just keep this as the runway and this as your vertical profile. So usually this is at 3 degrees. Okay, the aircraft will follow this path vertically as it will come down. It can't be too high because then the aircraft will land in the middle of the runway. It will eat up too much runway. It can't be low because then it will land short of the runway. It has to be exactly on the glide path. So this we call the glide path. So an ILS has got two signals. One is called a loc or localizer, and the second one is called glide slope. This is for your lateral guidance. This is for your vertical guidance. You just need to know that for now. Now if you go back to the Lido chart again, right? So this is the star chart. It doesn't tell us about the glide slope. For that we have another chart. So if I will open here, ILS chart 25 left, you can see here this one, right? Here you see. So the localizer signal in Karachi was actually a 3.03 here. Let me point it out to you. See this 3.03. It is slightly even higher than 3 degrees. So that means it was a slightly steeper approach as compared to a normal 3 degree glide slope. So again, here also we can see this is the point Makli here. They were coming on this 075 radial of Karachi VOR, and this is the localizer you can see from here. Okay, this is the lateral guidance, and the center line is your vertical guidance, which will take you exactly on the runway 25 left at Karachi Jinnah International Airport. So for now, just follow the areas which I'm highlighting, because otherwise it will be very confusing for us to understand, basically, because the chart presents a lot of information. Okay, all I want you to look at right now is that this particular image over here, GP stands for glide path. So it is, oh, correction. So it is actually at a 3 degrees. Sorry, my bad. It says localizer. Okay, so if you're coming for lateral guidance, then it is 3.03. Otherwise, for ILS, it is 3 degrees. That's right. Okay, so you can see here, this is your glide path. It will keep you exactly on 3 degrees, and it will allow you to land exactly at the touchdown, which is called the touchdown zone for the aircraft to land at. And we were told earlier in the report that the controller asked the pilots to be at point Makli and 3000 feet. Remember, initially first they told come down to 10,000 feet, then 5,000 feet, then 3,000 feet. This was actually supposed to be done. Now let us see what actually the pilots did. So we'll go back to our report. Okay, so referring to paragraph D now, the aircraft ended up higher than the required descent profile. Now, this is what we all know, that they were actually a lot higher than they were actually supposed to be at. At point Makli, the aircraft was at 9,780. So let's say almost at 10,000 feet. That means 7,000 feet higher than what they were actually supposed to be at. And they were at 245 knots. So they were not only high on the profile, they were also a lot more fast. They they shouldn't have been at this speed. They should have been a lot at a lot lesser speed than this one, and we will see exactly why this happened. In order to manage the descent, so now the pilots realized that they were actually coming in really high, and to lose the additional height, an open descent mode was selected via the FCU. Now this terminology is very specific to the Airbus aircraft, and I will have to explain this again by using a notepad. FCU stands for Flight Control Unit. This is a panel on the Airbus aircraft wherein you control the automated flight from. So all your automation controls are done from the FCU. In fact, to make it simpler, let me explain that with a little more detail. An open descent, okay, fine. Again, I'll have to keep it very brief because this is very specific for Airbus pilots. And both the autopilots were disengaged and speed brakes were extended. Okay, again, if you are not coming from an aviation background, I will need to explain this in a lot more detail. Otherwise, it will become very difficult. So let us see. So let us talk about the open descent. Okay, what is this open descent exactly, and why did pilots do this? Now, when pilots are trying to descend via open descent mode, this is basically a mode in the automation. Okay, what they're trying to do, they're telling the engines, hey, reduce the power to minimum. So thrust is at idle. Okay, and it says that now you will try to descend using thrust idle, and the speed of the aircraft now will only be maintained through the pitch of the aircraft. So if the aircraft pitches down more, the speed will increase. If the aircraft pitches less, the speed will reduce. So essentially, it is, to keep it simple, it is one of the faster ways of descending down. The other mode in Airbus is called descent mode, but I'm not going to talk about that right now over here. So with open descent, you can basically increase your descent much faster. So because you're reducing down your engine power, which means that now the aircraft will have an inertia, the tendency to basically lower down its nose, especially if I select a higher speed. So let's say I'm at 250 knots right now, and I want to descend with thrust idle. I'll choose open descent. The aircraft will try to pitch the nose down and maintain 250 knots. It will maintain that speed with the thrust idle. So the nose of the aircraft will try, because the more the nose dives down, the more higher the speed. The less the nose dives down, the lower the speed. And how much the nose changes its pitch, that depends upon the speed that I'm trying to command. So let's say from 255 I go to 270, the aircraft nose will pitch down even more. 300 knots, the aircraft nose will pitch down even more. But the thrust will continue to remain at idle. Similarly, if I'm trying to maintain 220 knots from 250 knots, the aircraft will try to pitch up slightly. But at the same time, my descent rate will reduce. So in order to descend faster, I will have to go open descent, and I will have to go higher speed, the maximum speed. It is very difficult, imagine, to basically descend and decelerate. So what you're trying to do is you're trying to keep the high speed for as long as possible, provided that there is no restriction and ATC has allowed that, and until you reach the required altitude. In this case, they had to come from 10 to 3000. They will continue to maintain that high speed, and then they will reduce the speed, and then they will basically configure the aircraft in the following cases. So that is basically open descent mode. Now I would really recommend that you can get more information on YouTube, and I especially would recommend this particular channel by Mike Begnell, wherein he explains what is open climb and open descent in A320. I will explain about this topic as well, but that is for another video. How this information is presented to the pilot, it's through your PFD, which is called primary flight display. So here on top you will see thrust idle, open descent. Thrust idle meaning that your power is at idle. Open descent, I'm going to go with open descent. So let's say if I have an altitude constraint, I will not respect it. I'm at 10,000, and let's say there is an ABC point on the way wherein I have to be at 5,000. So so basically this is thrust idle open descent mode, and this will straight away take me to my new selected altitude. In this particular case, they would have gone from whatever altitude they were at, they would have selected 3000, and they would have selected open descent, and I think they were at 245, 250 knots, and they could have increased the speed even more. But it seemed that they were in a very difficult situation because they were already very close to the airport, they were very high, and they were very fast. They should have ideally discontinued that approach. They should have gone in a hole, they should have circled, they should have descended down instead of trying to shoot that approach, because God knows what was going on in the minds of the pilots at that point in time. So this is called primary flight display. On the left you can see the speed, on the right you can see the altitude. So here you can see in this particular picture that the pilot wants to descend down to flight level 340 or 34,000, and currently they are at 34,300, and you can see that the vertical rate of descent is 900 feet per minute on the right. Again, a lot of information presented over here, but I'm not going to delve so much into it. And referring back to our original report, did we miss out on anything? I think we covered almost all the topics from there. So point number D, open descent is covered. FCU, yes, and autopilots were disengaged and speed brakes were extended. Again, this was done because when you disconnect your autopilots, you can descend at a much faster rate. The Airbus has the system designed in such a way that with the autopilots engaged, your speed brakes, but the question is, what are speed brakes? So again, let's go back to our favorite dear friend Google, and let me explain you. Speed brakes A320. Okay, so let's go to images. So these are your speed brakes. Where are they? Here. Okay, they are located on the upper surface of the wing. You can see it is extended upwards, and you can see underneath what is all the hinges and the points. What it does is it basically blocks the airflow. The airflow which is coming over the wings, it is generating lift. So by raising them, you're breaking that airflow and you want to reduce your lift. And they continue to extend upwards at a certain angle. The maximum deflection will only happen with the autopilots disengaged. If the autopilots are engaged, they do not deflect at a maximum angle, so you don't get the highest rate of descent. Now the pilots knew that we are in a very tricky situation. We must disconnect the autopilot, and this is recommended, right? Airbus does recommend, if things are not going in your control, you can disconnect the autopilot. Take control when things are not going your way, and this is one of the golden rules of Airbus philosophy as well, and that is what they did. But I think that it was too late for them to take this measure. But anyways, this is what they did. Referring to paragraph E, Karachi approach inquired, confirmed track mile comfortable for descent, and later advised to take an orbit. The controller was in a better position to understand that the pilots were actually not on the right vertical profile. They were too high, they were too fast. He actually confirmed with them, with the pilots, that how many track miles do you require. Why did he do that? Because in aviation we have a general rule of thumb, which is that if you are at a certain height, you can calculate, as a rule of thumb, I wouldn't say this is 100% accurate, but it does add up, the math does add up at the end. So let's say you are at 1000 feet, okay, this is your aircraft and this is the ground. You have to come down 1000 feet. So we follow a rule which is 1:3 rule in aviation. For every 1000 feet that you would have to descend, you need 3 nautical mile. So basically, if they are at 10,000 feet, right, and they had to come down to 3000 feet, which means they have to lose 7000 feet. So 7 times 3 is 21. 21 nautical miles was the minimum miles they required to basically descend down and come to 3000 feet. Remember, they were already 15 nautical miles out. The point Makli is at 15 nautical miles. Okay. And they require 21 nautical miles. So that means they were never ever going to be able to make it down to the runway, given which height and what speed they were at. Now 21 nautical miles is the minimum that is required. There are certain factors that we need to consider. We need to consider your speed as well. They were at 250 knots and landing speed is close to 140 knots. So let's say they had to reduce almost about 100 knots for this. So they needed about almost 10 nautical miles even more. So 21 plus 10, 31 nautical miles. Okay, then we don't know about the headwind or tailwind. If there was any tailwind, then we would add 10% of the tailwind component. Or if there was a headwind, okay, then we will reduce. So minimum, let's say they needed 30 nautical miles from Point Makli, and they only had 15 remaining, meaning they needed twice the track miles, and no confirmation was given by the pilots as to how many track miles are required by them, because they said we are comfortable with the approach, sir, we will make it. So that showed that they were overconfident. They had developed this notion that we are going to land, come way mud, whereas the controller was actually giving them a suggestion. He told them, please take an orbit. You cannot come down on the ground with so much of height. You will be coming in really fast. So this was basically where the accident was brewing. It had already started. The ingredients were laid out so that the aircraft can be adjusted to the required descent profile. No orbit was executed and the effort to intercept the glide slope and localizer was continued. The pilots decided that we are going to go and shoot this approach. When you say intercept, that means that you have to intercept the two signals, the vertical profile and the localizer. Okay, so that you're coming on the center line of the runway and you're coming on exactly the right profile. Let's go back to the drawing. So this is what happened actually with them. Okay, so they continued. Let's say this is your runway. Right, this is your runway and this is my actual profile. So they were supposed to come from whatever height down to 3000 feet at Makli. However, they were somewhere over here at 10,000 feet, and ideally the aircraft should have come like this. Okay, 3000 feet, and then I will intercept the signal, which is my 3-degree signal. Okay, and the signal will continue, and then I will intercept my lateral signal as well, just to keep me on the center line of the runway. You always establish localizer signal first. So first the aircraft will come on the center line. Once it reaches at this particular point, we'll go back to the chart. Okay, this was I think 6 or 5 nautical miles. You will intercept the glide slope. From here on, the aircraft will descend continuously until it touches down. Here the pilot intercepted glide slope from above, not from here, but from above. Now there's a risk that it could have been a false beam, which means that, see, there's a limitation of ILS system. There are certain false beams generated as well. So let's say this is one beam, this is one beam, this is one beam, this could be another beam, and false beams are generated above as well as below the actual profile. You see this? I'm not going to go again too technical, but I'm just saying that there could have been a very high probability that they actually intercepted the wrong vertical beam and not the actual beam that they were trying to intercept. But anyways, so they continued with their approach, and what did happen after that? Let's find it out. The FDR, which is the flight data recorder, indicated action of lowering the landing gears at 7,221 feet and at around 10.5 nautical miles from the runway. So they tried to lower the gear down, which is not at all as part of the standard operating procedure, but they did that because again they wanted to descend much faster and they were trying to increase their drag. They remember I told you that they extended the speed brakes, they disengaged the autopilot. Why? Because they wanted to increase the drag, they want to reduce their lift, they want to descend down faster and faster and faster. So they're using another strategy by lowering the landing gear. See, all these are not your standard operating procedures. These are measures that pilots can take as part of airmanship. Okay, but they were not following their SOPs. They thought, now we are too high, now we need to do this. Oh, now we have something else wrong, now we are going to do that. They were just trying to take their flying approach in a very reactive manner. They were not ahead of the aircraft, they were not anticipating what the aircraft will do. They were actually reacting to what the aircraft was not able to do and then trying to correct that. While they were trying to correct that, something else was going wrong, and hence they were so overconsumed, they were so disoriented and probably illusioned by trying to control their descent profile, that they actually lost track of where the aircraft actually was, what they were supposed to do. The controller told them, probably it did not register to them. It does happen, you go in a zone where you get so disoriented and disillusioned that because you're too over consumed by the information that you have, you're so stressed out at that point in time that you do hear what the controller said, because they did acknowledge his message by saying, Roger, we are comfortable, we will make it, but they did not process it. They did not understand what was happening, the consequences of their action, and why the ATC was telling them what he actually told. So coming back to the point here, so they lower the gear at 7221 at 10.5 nautical miles from runway 25 left. Now we need to look at the Lido chart. This is very important for us because this will help us to understand exactly what went wrong in the final phase of the first approach. Let me explain this. This is the vertical profile, okay? And this is the top-down profile, basically. This one and this one exactly show the same information, but in different layouts. So let's say 7,200 is when they lower the landing gear. Okay. Let me pull out my highlighter. Okay. So let me extend this glide beam somewhere. Okay. This is again your extension of 3 degrees. Remember, as you go higher and higher, there's a false beam. Okay. It may not be the true glide slope beam which will take you exactly onto the center line at the right touchdown zone of the runway. But anyways, at 7,200 feet, sorry, let me just go back, and at 10.5 nautical miles. Okay, you see this here, this is 9.1 nautical, 9.1, so somewhere over here, let's say 10.5. okay, this is 10, this is 10, this is 1 2 3 4 5, 10.5. So let's say here 10.1, somewhere over here they lowered the landing gear, okay, because they wanted to reduce the height. While they were supposed to be at 3,000, they were still at 7,200. Again, how much they had to lose? They had to lose close to 4,200. How much did they require for that? So 4 times 3, 12. So minimum 12 nautical miles is what they required. And how much they had in order to intercept the glide slope? Only about 1 nautical mile left. They were definitely coming too high. All the indications were there. The aircraft was telling them. The controller was telling them. They knew it. They decided to continue the approach. It is like a macho attitude. No, I will do it. Was it the captain who was pilot flying? Was it the first officer? I think it was the captain who was pilot flying. But this was a recipe for disaster. They lowered the landing gear. Okay, they wanted to descend much faster. So right now I'm telling you what they did. What actually they should have done, I will tell you a little later with the help of this profile. And they lowered the landing gear. Karachi approach advised repeatedly, twice to discontinue the approach, and once even cautioned. So he was doing his part, but at the end of the day, it is the pilot flying who's flying the aircraft. The controller is not flying the airplane about excessive height. Landing approach was not discontinued. However, FDR shows action of raising of the landing gears at 1740 feet, followed by the retraction of the speed brakes at a distance of slightly less than 5 nautical miles from the runway 25 left. So this is a point of confusion. They extended and then they retracted the landing gear at 1740 feet, followed by the retraction of the speed brakes. I will have to read more about this. Was it the system design of the Airbus A320 that led to this? But the gears will not be retracted by itself. This action was taken for some reason, which has not been stated because we don't have the cockpit transcript. And the speed brakes were retracted. Probably at this point in time, the decision was to make a go around, but let's see. At this time, the aircraft had intercepted the localizer, which means that it was on the extended center line of the runway as well as the glide slope. So it was on the vertical profile, it was on the lateral profile. It was just too high. Now this is the biggest blunder, and I don't know why they did this. Flap 1 was selected at 243 knots. So you extend your flaps because you want to lower down your aircraft speed. But if you continue to slow down the aircraft speed, the aircraft will not be able to maintain the lift. So now in order to maintain your lift, you're going to select flaps. There are 4 configurations: flap 1, flap 2, flap 3, flap full. You can land the Airbus A320 in flap 3 or flap full. There are different parameters which you have to consider operationally, environmentally, as well as commercially in order to determine which flap position should be recommended. But as a general understanding, flap 3 will consume less fuel as flap full, because flap 3 you're coming in at a slightly higher speed. Okay, with flap full you're increasing your drag and you're coming at a much steeper angle. So both are important. One has its own pros and cons, the other has its own set of pros and cons. But there's a limitation as to when you can select your flap 1. The speed is 230 knots maximum. You have to be at 230 knots or less in order to select flap 1. They selected flap 1 at 243, which is a violation, which means your flaps can actually get damaged because of the air resistance, because of the airflow over the wings. So this would have definitely generated a warning. The landing gears and speed brakes were retracted, which is what we know. Landing gears and speed brakes were retracted. Now they retracted the speed brakes because they thought, okay, now it's time to configure the aircraft. So we can't extend the flaps at the same time, which is like trying to say, hey, I want the lift. At the same time, you're extending the speed brakes, which means that you want the aircraft to descend faster. So it's counterintuitive. And overspeed and EGPWS warnings were then triggered. Overspeed, definitely, because they were overspeeding. They exceeded the 230 knots limit for flap 1. EGPWS, because they were coming in at such a fast rate that it's like terrain. Their vertical speed was, I think, in excess of 2000 feet per minute, which told the aircraft systems that you're coming in at a much faster rate, so slow down. Okay, so referring to paragraph G, which is the figure here under, it basically shows the comparison between the actual profile of the aircraft and what the profile which was required, which should have been followed. And we can see that on the right as well, the depicted chart, whereby we can see what exactly should have been flown. So if you notice here at Point Muckley, which is a 3000 point, and if you can refer to the chart here on the right as well, that at Muckley here, right, you should have been at 3,000 feet and above. So this 3,000 feet and above is a restriction that by the time you reach Mach, you should be 3,000 feet and above. And in very interestingly, there was a hold as well. Now, what is a hold? Hold is a racetrack pattern wherein pilots can, uh, continue to hold in it until they have further clearance, or let's say they want to descend while they are in the hold, or if there is traffic and the ATC cannot give you the landing permission. That is why the ATC continued to assist. Orbit is available, which was at Point Muckley, which is the officially published hold. Here also you can see at Muckley, the pilots could have held and they could have bought some time while they could have reduced their altitude enough so that they could come down to 3,000 feet. Now, that they did not use. They had complete information, they had all the resources available, and they did not do that. Moving to the chart on the left, so 3,000 point, and they were actually about close to almost 9,000. If you see, the blue line is what was the actual profile. And look at this steep descent over here. It basically tells you in what disastrous situation they were. The aircraft should have been over here at 3,000 mark, and then it would have followed this glide slope, which is exactly the line that we have over here, which is this one. Right at 3,000 feet, it would have intercepted and it could have followed the glide slope. Now, gear was selected down close to here, 7,500 feet, because look at the impact. Once the gear was down, look the kind of rate of descent they could achieve. This is a little shallow and this is much more steep. And here the ATC informed, sir, orbit is available, which they did not take. Then the ATC says left heading 180. Left heading 180. Well, I believe this was largely being given so that they could take a hold, but they did not take it. And ATC said negative, turn left heading 180 again. That also they did not follow. Then they selected the gear up over here at this point in time. So once they were on the profile, what was going on in their minds, nobody knows, but they selected the gear up. While if you're in normal configuration, your gear should be down by now. This is where the entire disaster took place. This was the final, nail which was hammered for this accident, the retraction of the landing gear. And once you are below 750 feet, you get the warning as well, too low gear, and it is too difficult to miss this warning because you have oral warning, you have visual warning, that this warning cannot be missed. And then they basically went down and scraped the runway, and this is the go around profile. Below you can see the different configuration of slat and flap. Here, see, flap 1 was selected when they were close to 245 knots. They exceeded the limit. From flap 1 they went to flap 2, flap 3 directly over here, as you can see, while the speed was about close to 230 knots. Now flap 2 is selected when you are below 200 knots. This was again exceeding the design limitation. Flap 3 is selected when your speed is below 185 knots for Airbus 320. This was also exceeded. So all the while they continued to extend the flaps because now they had to slow down the speed, but the aircraft was moving so fast that it could have actually damaged the flap configuration, and it would be very interesting to see if the flaps were actually found to be damaged before the accident took place, if analysis can be carried out on that. But I think it will be very difficult because of the hull loss. The structure has been damaged beyond repair. Continuing with the report, note, for descent path, the altitude has been shifted to start from 84 feet in order to match the altitude of the runway at the ground impact, which basically means the elevation in Karachi, if you will follow me here on this chart, is 100 feet. So it is 100 feet above the sea level. That is why all the altitudes start from 84 feet. They have rounded it up to 100 feet. Paragraph H. Since the approach to land was continued, Karachi approach, instead of changing over the aircraft to aerodrome control, this is basically your tower. So first you had the area control, then you had Karachi approach, then you had aerodrome control, which is basically the tower which is at the airport who gives you the final landing permission. The Karachi approach got the clearance from the tower through a telephonic landing clearance from the aerodrome control. The aerodrome control of the tower conveyed landing clearance of the aircraft without absorbing the abnormality that the landing gears were not extended. So the clearance basically was given to the aircraft by the Karachi approach to land by consulting it from the tower through phone. So the aerodrome control did not convey the abnormality that your landing gears are not down. They got a call from Karachi approach. They said, okay, landing clearance is given, and they themselves failed to see, because they can see from the tower. They have the visual sight of the airplane when it is coming into land, that the landing gear was not extended, and nowhere in the ATC conversation do we have a recording of that. Subsequently, Karachi approach cleared the aircraft to land. At 500 feet, the FDR indicates that the landing gears were retracted. Now this is where we can't understand why would you retract, because 1000 feet is your mark for your aircraft to be stable. That means you're in the right configuration, your landing gear is down, your speed is in control, your thrust is giving enough power, and then they retract the landing gear again, which is a breach of the SOP. Slat flap configuration 3 was selected. Airspeed was 220 knots, which is far above 185 knots, because that is the limitation for configuration 3. Descent rate was 2000 feet per minute. Actually, your descent rate should be about 1000 feet per minute as per the SOP, again a breach. According to the FDR and CVR recording, several warnings and alerts such as overspeed because they had exceeded the flap speed, landing gear not down. Like I told you, below 750 feet, you will have the warning, too low gear, and ground proximity because their rate of descent was more than 2000 feet per minute. All different warnings were being heard in the cockpit, and we can hear this in the cockpit voice recording as well. The chimes, ting 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 ting, is an indication of this. The landing was undertaken with landing gears retracted. God knows why. The aircraft touched down the runway surface on its engines, as you can see in the pictures below, as captured from the CCTV located at the airport. Flight crew applied reverse engine power and initiated a braking action. So now they must have realized what a difficult position they have gotten themselves into, and they have to land. So they use a reverse engine power to slow down the aircraft, and they initiated a braking action. Okay, how would the aircraft slow down if there are no brakes? But obviously they were trying to brake the aircraft just using the reverse engine power. Both the engines scrubbed the runway and were at various locations which caused the damage to them. Figures here under show the screenshots. Basically we can see the sparks which are being generated from the engines because of the fuel, and this scrubbing basically led to the failure of the engines. The engines were completely in good condition. However, because of the physical damage that was sustained by the engines when it went for a go round, it lost power on both the engines. So paragraph J, the aerodrome control observed the scrubbing of the engines with the runway but did not convey this abnormality to the aircraft. The air controller should have informed that you have carried out a belly landing, but there was no recording or any mention of this information from the controller to the pilot. It was conveyed to the Karachi approach on telephone rather. So the controller rather informed the approach. After the go around was made, the ATC communication shifted once again from the tower controller to the approach controller. And the approach controller was informed by the tower controller that the Airbus A320 PIA 8303 has made a belly landing, but not to the pilots. Now that is again a little surprising, that the ATC should have informed or should have given him the warning that you have actually carried out a belly landing and your landing gear was not extended. The warning should have come out even before the aircraft touched down on the runway. Subsequently, Karachi approach also did not relay this information to the abnormality of the aircraft. In fact, we can hear in the cockpit voice recording that the controller confirmed, are you carrying out a belly landing? Now that was not required, because The controller should have been informed of any given emergency. The controller could have asked, "Are you declaring a mayday? Do you have a problem with your landing gear?" But rather, he confirmed, "Are you carrying out a belly landing?" Probably because this was the information which was passed over by the tower controller to the approach controller. Moving to point K, the landing was discontinued and a go around was executed. The recording indicates a brief action of selection of landing gear lever to down position. So, probably this might have happened while the aircraft was scrubbing on the runway, which was immediately followed by its movement to up position. And then, probably, the pilots realized, or in haste, they just put it like up straight away. Intention to undertake another ILS approach for landing on runway 25 left was conveyed because they had to come back for landing. However, shortly after the go around, both engines failed one by one because of the damage sustained while they were being scraped on the runway. Ram air turbine was deployed to power the essential systems. Now, ram air turbine is a small fan which is deployed from the belly of the airplane. Once you lose your generator capabilities from both the engines, you have either auxiliary power unit which is located in the tail cone of the airplane, and even if that is not working, the ram air turbine will automatically get deployed, which will give you just the bare minimum electrical needs for the cockpit display systems and other electricals to work. The aircraft was unable to maintain the required height. The controller asked the aircraft to climb and maintain 3000 feet. However, they were barely able to reach 2000 feet. I think they were hovering at around 1800 feet and transmitted a mayday call. This is the first indication by the pilots that something is wrong. Mayday call. Evidences from the wreckage indicate reasons for right engine failure. However, left engine requires further examination. So the right engine had completely failed, but the left engine is still being investigated if it was power failure. And landing gear in extended position did not demonstrate any malfunction of the landing gear system. When they were coming in for the second approach, the landing gear was extended down, and it did not signify that there was any fault in the landing gear system. The aircraft was reportedly serviceable for the said flight. Necessary scrutiny of the aircraft maintenance records documents is underway. Captain and first officers were adequately qualified and experienced to undertake the said flight. Necessary scrutiny of the aircrew records documents is underway. So we need to check basically whether the licenses of the aircrew were valid, were they proficient and current enough. Now, following the release of this report, it has also been found that there are a lot of fake license holders in Pakistan, and almost about one third of the pilots have been suspended on suspicion that they are carrying illegible documents. This is a huge eye opener for the aviation industry, and especially in Pakistan, whereby it is being understood that a lot of pilots got their exams cleared when somebody else actually sat for their exams, and they are not even technically qualified to undertake flight operations while they are actually being employed as pilots in Pakistan. The rest of the report basically summarizes the entire report once again and the future course of action which will be taken. This is a preliminary report and not a complete exhaustive report, but it does give us a fair idea about what led to this accident. What we need to understand is this, that every accident is caused by a chain of events, and the accident in this case occurred not just because the landing gear was not extended, but due to several factors such as they did not follow the SOPs, there was no crew coordination, the crew resource management principles were not followed, they did not support each other, one did not become assertive if the other one was making mistake. If the captain was trying to take control of the airplane when he was doing it incorrectly, the first officer could have actually prompted the captain or could have taken the controls if he determined that the aircraft was not in a safe condition. But there was no such assertion made on behalf of the first officer. Very unfortunate that this accident took place, because this was a very avoidable accident. But it's not time to blame or shame anyone, but rather to learn certain key elements of the human factors and ensure that such a tragedy, which was totally avoidable, is never repeated once again in the future. Thank you for watching this exhaustive analysis on the Airbus A320 crash, Pakistan A303. I hope that it did add to your knowledge. In case you would like me to clarify anything that I have discussed, mentioned, or something that I could not clarify, or rather you would like to give more inputs, or would you like me to discuss any aspect or topic further, do put it in the comments. I would really appreciate your feedback, whether it is positive or negative, because it will help me to continue to put in effort and make videos in the future as well. I encourage you to kindly subscribe to the channel for any future updates on aviation or non-aviation related aspects. Aviation is my forte. I will continue to post whenever I can. And thank you for watching. Kindly do subscribe, like, and share the video with your colleagues, family, friends, and spread the knowledge. Thank you so much.